I'll just go through a couple of slides to set things up, and then I'll turn it over to Jeremy because Jeremy is the kind of guy in our team that you would work with when you work with BP3, and I think I'm just here to wash dishes and set the stage for our consultants to go out and do their work. So this will be no different. First, just a quick moment about what does BP3 do. I know we're new to CamundaCon. I've known Jacob and the Camunda team for a long time, since before there was a Camunda engine. We've been friends in the BPM space, and I think it's one of the things that I love about process is how many people really find a love for improving their businesses and the technologies that go behind it, and that community has been really long-lasting for us. Much like many other development communities, you find a really good community there where people stick together and work together over a long period of time, even if they're not in the same organization. So for BP3, we have been in business process for a long time, since 2007. And before that, many of us worked for another firm that wrote BPM software, but our real love was for helping clients achieve success with process technologies. And that brought us into adjacent technologies like decision management and content management, but we still have that core focus on process tech. And I will say, thank you for the intro, Felix. He mentioned that we're a Camunda partner in North America. We've had some great successes together with mutual clients in North America. But today, we wanted to focus a little bit on cognitive request router. And basically, this is a problem that many of our clients have, where they have inbound communications and a high degree of customer service that they have committed to their client base. And how do they handle that inbound set of communications in a reliable way and have certitude that they're handling it both correctly and timely? And we'll go through a couple of examples of why that might be an issue. They, in many cases, can receive these communications via phone, web forms, emails, snail mail. Believe it or not, some of our clients will take a letter in the post and treat that as a contractual requirement, right, that they respond to it. When we receive those items, we want to classify them, track them, route them to the right places for processing, and then use the classification routine or use that round tripping as an opportunity to also train the routing, right, so that the routing gets better over time. After all, if we're reading someone's text or we're doing OCR off of a piece of paper, and then we're trying to understand whether it's a termination or a cancellation or a change of address, things like that, we want the opportunity for humans to improve the training and improve the algorithms that go behind that. As an output, we may just be doing something as simple as forwarding the email to the right person. We may be starting a process. We may be implementing decision matrix, or we may be handing off to a custom application, right? Any sort of application. So that's sort of the high level. In a specific customer context, right, we may get more detailed and give them a more specific architecture with their systems, their people, their teams, where the routing is likely to go to help them get the right kind of visual to understand it. And a couple of examples that we can talk about. In banking, we have a large North American credit union that gets over 3,000 requests a day through various media, not all email, not all in a structured web form environment, but across all forms. And it turns out that when you look at all those inbound requests, despite the fact that they seem sort of open-ended, they actually boil down to a few categories, right? It's a finite number of actions that our client needs to take on those. And so using the cognitive request router, we're able to handle many of those automatically or straight through processing with no human interaction. And many of those we could augment the human interaction so that it gets teed up correctly with other information, so that if I'm in the call center, I can handle it quickly rather than I have to go figure out all the background information about that client before taking action. So they were able to save 16,000 FTEs, FTE hours in a year based on that, which is a nice outcome for them. And in pharma, in the US, and I'm sure in Europe as well, although different regulatory bodies, in the US, adverse event reporting is a federal requirement, regulatory requirement. The volume of these adverse event reportings is increasing, and it's increasing because as more drugs get out into the market and people are using them in not always in the way they're prescribed, or they're in combination with other drugs that maybe the doctor didn't know you had prescribed. You get these sort of complicated cross events, right? Interactions between those drugs. So again, this is the kind of thing where you get these reportings. It could be social media, post on Twitter, is actually something that falls under the regulation, right, where they have to actually investigate those incidents if they rise to a certain level of certitude, right? So that they have to do the research on each of these adverse event reports. And the whole point is to try to save lives, to figure out if there are adverse reactions between different drugs. So this is a kind of key thing for pharma companies, and they're not the health providers, right? They're just producing the drugs, but they still have a responsibility to understand how those drugs interact in the real world. And these are complicated interactions that can't be resolved in clinical trials. Order management is another sort of obvious use case. And in one case for a client, as they were ordering or dealing with orders for parts, they had a single human point of failure, right? And when you have that sort of single point of failure, you look for ways to design around it. And it was, in their case, literally one person responsible for handling all of the inbound requests. And they had all the organizational knowledge to do the work. But the challenge is when that person is on vacation or sick, then everything waits till they come back. So we had to give them an automated way to have a backup for that person, and then they could just focus on the things that really don't go through in a straight-through processing manner. With that said, I'd like to kick it over to Jeremy to show you a little demo.
Thanks, Scott.
Yeah.
All right, so gonna just update the display preferences really quick. So what we're going to be looking at today is a pretty straightforward example, a banking example for what we've done. We basically have, a bank, like Scott said, that's receiving just a ton of requests. They have a number of BPM processes that can get started. Maybe they've built a new web portal and they want everybody to essentially use that web portal, but they have a lot of customers that are stuck on old deprecated software. They're getting requests from phones, they're getting requests from emails, from paper trails, et cetera. So we basically want to be able to, take the human interaction out of that and be able to automate a lot of it. So we have a couple of Camunda processes here, basically a delete customer account process, a delete a lost credit card process, an update account information process, and essentially a handle uncategorized request process. So the use case that we're going to be looking at today is we're going to send a couple of emails from basically a user of the bank. They're going to send it to an email inbox. The cognitive request router is going to be monitoring this inbox, and what's going to happen is every email that gets sent to this inbox gets analyzed, classified, and with a degree of certainty, and then if the degree of certainty is high enough, then it will route it to the associated process. So a couple things we want to just get ready. Starting up the email monitoring.
Like the branding of getting the Camunda model out there up front.
Yes,
that's good.
exactly.
That's good.
So what we have here is, that didn't work. We have the cognitive, does everybody see this okay? We're going to zoom in a little bit. Right, so this is the cognitive request router. So what we have is, we essentially have defined delete account, lost credit card, and update account information. So these are pretty straightforward classifications, right? And these classifications are associated with the BPM processes that we just discussed earlier. And then so we can define these classifications, and then we can basically choose a route to route these classifications accordingly. So basically with this routing, we can either forward the email, call a REST API, and we basically have a threshold where we define what degree of certainty the cognitive request router should route it to the associated process, and if it doesn't meet this degree of certainty, then we can essentially route it to an uncategorized process where a human still would handle that. So basically this is something that you still require a little bit of human interaction, but what we've seen on previous implementations is things like 80% of these requests get routed automatically. We're able to then go back in and retrain the data and basically increase that threshold each time. And basically what ends up happening is you get just able to automate, and the model gets stronger and stronger as kind of machine learning algorithms do. So we also have this train email or train tab where basically we've pre-populated the cognitive request router with a number of different messages that we've received from customers in the past. I lost my credit card, can you update my email? Can I delete my account? So these are things that we receive quite often. We know exactly how to route them. They're very straightforward. So we've basically trained our model with this sample data. And then from here, we're going to essentially send some new requests in. Some of them are going to get routed automatically. Some of them are going to be uncategorized, and we'll kind of walk through a demo of that. So we also have the Camunda task list up and running as well. So we have no tasks currently in Camunda, but we're going to go over here to this user's email. I'm going to email the cognitive request router inbox, say, I lost my credit card. Can you send me a new one? So we're going to send this email. It's going to take a second to arrive in this inbox, but basically this is the cognitive request router inbox that we are essentially monitoring for any inbound emails. So we've received the email, and then we're going to go over to the Camunda task list, and we see that we have a new task, right? So this has been routed to the lost credit card process. So we can claim this task, and we'll open it up. So this is the lost credit card task. So these UIs were built in our Brazos framework, which is kind of our internal framework to build out custom UIs. Helps, big accelerator on delivery projects for us, just being able to build out quick UIs. So what we see here is basically we see that it's pulled some customer information from CRR user 1. The email subject says, I lost my credit card, and the body is, I lost my credit card, can you send me a new one? So this is a very straightforward request. Basically, we can, this is a good opportunity on past clients. We've paired this with some RPA technologies. Sending a customer a new credit card is something very straightforward. It's a couple clicks. You select the customer. You say you need to send them a credit card. So we can, this isn't an RPA demo, but we're just going to do some straight-through processing here. We're going to complete the task, and we're back to our inbox. So the second email that we're going to send is missing unit number. So unit D34 is missing from my address, right? So this is a customer that, potentially said, hey, I see my address on my account. I don't know how to update it. Can you update it for me? I just need the unit number to be there. So again, we're back in the inbox, waiting for an email to come in. So the emails come in. We'll go back over to the Camunda task list. We'll refresh, and, oh wait, we have to, there we go, refresh. And so route request, handle uncategorized request, right? So this is an uncategorized request. We don't know what to do with it. So we'll claim this task, open the form. So again, same user, similar email, missing unit number. Unit D34 is missing from my address. So we see down here that this is the process classification. So the attempted classification is it attempted to route it towards update account information. However, the confidence level was only set to 70%. So cognitive request router was only 70% sure that this was the right way to actually route the request. And we had the confidence threshold set at about 90%. So it did not meet the threshold, therefore it routed it to an unknown request, uncategorized. So we can select update account information, where we're going to actually manually route it to the update account information task. We're going to complete that, and now we have a new task in our inbox where we can actually update account information. It's been routed accordingly. We can take this, we'll open the external form. So same thing, same email, but now we're in the update account information. I have all of the information that I need to actually update this user's account. I have their, all of their information, but we can see that the unit number D34 is missing from their address. So we can add that in. We don't need to send it for admin review because it's very straightforward. We have all the information that we need from the customer. So we can go ahead and complete this task, and we're basically done with our work. So from this standpoint, we've essentially completed our work, eliminated a lot of the human interaction, but then we can come back over here and look at this Analyze tab. And so this is where kind of things get a little bit interesting. We can actually analyze. Ooh, this is not playing nice.
That wasn't what you thought would happen.
All right, there we go. Well, it's not.
It's changing column widths instead of the window. It's just not going to let you pick the edge.
It's like a surgery.
Yeah. So anyways, so we have this analyzed. So unit D34 is missing from my account. We can click on this. We can see that update account information was classified at 70%. And what we can do is we can say, we're going to classify that as update account information, and we're going to add this as a training item for future model training. So this has been added as a training item. We go back over here to train, and we can see that essentially we have a new training item here. So all of the model has been trained, but we have this new training item here. It says, here's a new request that we got that we haven't seen before, but we know exactly how to classify this, and we want to actually train our model to essentially use this classification in the future. So the status is new. We could click train model here, but we're just going to do one more quick thing. So if we come back over here to define, another thing that we can do is say, what if we want to analyze? So it's not working with the modals, but we essentially add a classification. Say if we wanted to add a classification for route emails differently. So if a customer just had an email and they wanted to route an email differently, basically they could come here, select this thing. This was trained to originally update account information. You can modify this to a new classification, say route emails, and you get a modified status. Essentially, you can train the model, and then in the future, when you receive those requests, it would be able to route them with a degree of certainty, and when the model continues to get stronger and stronger. So basically, as the data gets more and more accurate, then your model gets better and better, and you can route more requests and eliminate more human interaction. So
sort of interesting thing is when you pair that with RPA, you can kind of gradually ratchet down the amount of manual work required to make these sort of updates, because the interpretation of the request gets smarter, and then the interpretation of how to act on it can get smarter as well with training over time. So it's a pretty interesting combination.
Yep. Right. So this is kind of a tool that we saw one of our clients or one of our customers had this need, and one of our consultants basically just built this kind of as a side project, and then it was a pattern that we started seeing quite often on different projects. So as is the case with a lot of the stuff that we use, basically saw that it was needed, built it, and so what we're doing is we're working on abstracting some of this stuff out, right? So the Cognitive Request Router is an Angular app that has a MongoDB backend. It uses the Watson Natural Language Processor, which is basically an IBM Bluemix tool. You have to have an account for that. We're exploring some open source options from a natural language processing perspective, and we want to basically be able to, kind of open source some of the code with regards to the natural language processing, and put an example out there. But this is a very new thing that, for us, and we're trying to figure out what we can, what we can do with it, and how we can basically, help people use this cognitive request router and see what the use cases are for it. So.
Yeah, and I believe that's it. Thanks.